This is Rob, one of your FSCJ Adult Education Academic Tutors, and in this video we are going to continue discussing vocabulary for math. We are going to talk about operations and indicators. So first, our first operation is addition and subtraction. It is addition that combines both or all numbers. You can have more than two. It is indicated by the plus sign. Then we have subtraction that removes from whatever our number is, and it is indicated by the minus sign. When we get into algebra, we will talk about combining like terms where we add or subtract, and that will deal with constants, which from our vocabulary video we know are numbers, or variable terms with the same variables to the same powers. Next up, we are going to talk about multiplication. Multiplication can be considered counting in groups. It has multiple indicators. As you can see, we have 7 times 5 written three ways, with the asterisk, with the X, and with the parentheses. We also indicate multiplication with variables in algebra by writing the number right next to the variable with nothing in between. Multiplication is commutative. That means the order does not matter. 7 times 5 is the same as 5 times 7. However, when we write a variable term, it is always given as number, then variable. And if the number is 1, we do not have to write that coefficient of 1. Division, it is the reverse of multiplication. It breaks a larger number down into groups. So we have 9 divided by 3 with the dot, bar, dot. This represents the fraction where our dividend is on top. Then we have our fraction bar and the divisor. So this is 9 divided by 3. Next, we are going to talk about parts. So fractions are numbers expressed as numerator over denominator, such as 7/12 or 3/4. They are division we aren't going to do right now, although we may at a later date. Decimals, these are parts indicated by going to the right of the decimal place, such as 0.73. If there is a whole number greater than 0, we do not need to put the 0. That 0 is just there to warn you there is a decimal point and to pay attention. Percents are a special kind of decimal or fraction. They represent a ratio of that number out of 100. So if you have 99%, that is 99 out of 100. Our fractions are rational. They can be expressed as a ratio. That is where rational comes from. Irrational cannot be expressed as a fraction, such as the square root of 2 and pi with all of its many digits. From fractions, we get ratio and proportion. Ratio, this to that, such as 1 to 4, and we can express that as 1:4, 1/4 as a fraction, or 1 to 4. From our ratios, we will get proportions, and they are equivalent from our equivalent fractions. And we can say this as 1/4, or 1/4, is equal to x out of 16, and we know that is 4 out of 16. We use these in unit rates and in unit conversion. So if I am converting from metric to conventional measure, I can say 2.2 pounds per every kilogram. On the other side, I have my pounds on the top, which I don't know, and how many kilograms I have. And if I follow the math, I will solve that proportion. Next, we have exponents. Exponents are both powers and roots. The power is a number multiplied by itself a number of times and uses the superscript. The Pythagorean theorem makes use of that with a squared plus b squared equals c squared. But in actual numbers, 2 squared looks like 2 times 2 and equals 4. 2 cubed, 2 to the third power, is 2 times 2 times 2, which is 8. Note, you are not multiplying the number times the subscript or the superscript. You are multiplying the number by itself as many times as indicated by the power. Roots ask us the opposite. They ask us how many times a number is multiplied by itself to give us the number under the root. We do not use a first root, so if we have not written a number, it is a square root. So the square root of 16 asks what number multiplied by itself is 16, which is 4 times 4, although we only have to write 1 4. The power tells us it's going to be written down a number of times. The cube root of 27, what number multiplied by itself gives you 27, and that is 3 times 3 times 3. When we get into algebra, we have two different but related concepts, and they are equations and inequalities. An equation, such as the area of a circle, a equals pi r squared, y equals mx plus b, or 4x plus 5 equals 25. These are all numbers to solve. We also have inequalities. Inequalities are treated like equations, but you read them with the greater than or less than symbol. So instead of 4x plus 5 equals 25, our first example is 4x plus 5 is greater than 25. We can also have 4x plus 5 is less than 25. If you have a greater than or equal to or less than or equal to, you read the or equal to as part of the inequality sign. In algebra, we also have like terms, and when we solve, we will combine our like terms. They are variables with the same variables of the same letter to the same power. So our like terms, we can say 7x, 5x, 2x, and x. These are all like terms. Likewise, 5, negative 12, and 32 are all constants, and they are all like terms. 4y and 3y are like terms because they all have y. An unlike term would be 3x and 4y. You cannot combine those because they do not contain the same variable. 3x squared and 5x likewise are unlike because while they have the same variable x, they are not to the same power. We have two different routes we can take in algebra. We have solutions where we manipulate the equation, and it can be an inequality, to identify the value that makes the statement true, whereas we evaluate 3t plus 4r is not set as equal to anything. They may give you values and say, what is 3t plus 4r? Then they will say if t equals and if r equals. And you will plug those variables in and do the math indicated. We also have a different route to go in algebra. We can graph. We are not looking for a value of x. We are looking for a value of x to give us a value of y. That means x can be any number. They are linear equations, they are quadratic equations. A special form of a linear equation or a quadratic is called a function. A function differs in that for every input, there is only one output. For every value of x, there is one value of y. Our last item we are going to talk about is subscript. Whereas exponents had the superscript, which was the letter up high, our subscript, it will be down low. We use this in slope, and it designates 0.1 and 0.2. You see y2, that is the second point. y1 comes from the first point. This is expressed as delta y over delta x, and we place our points where they go in the formula and can generate slope. Not on the math test, but math related, Subscript is also used in chemical equations, and we will talk about that in a separate video for the science test. Thank you, and keep learning.